And please do let me know if there's any issues with the audio throughout. I'd be happy to speak up if need be. So this is just going to be kind of an introduction and overview of Fedora 4, which is the now the production version of Fedora and has been in production since November of last year. So it's relatively new, and there's a whole host of new features and capabilities that I'd like to review in this session. So just to begin with, some of you may not be familiar with Fedora kind of generally. Fedora has been around for a while now, and is kind of based on this idea of it's actually an acronym, and the idea here is that it's a flexible, extensible, durable object repository architecture. It's a bit of a mouthful, but it does kind of describe what Fedora is and does. And so, Fedora is this open source project. It's what we tend to think of as community source in the sense that it's developed by stakeholders from institutions all around the world and not just one or two institutions in a particular location. And it basically stores and preserves and provides access to digital objects. But as well as that, Fedora is really designed to integrate with other applications and always has been, but Fedora 4 in particular is much further along in this goal. So you can kind of think of Fedora as middleware that sits in a larger software stack to provide repository services. But for those of you that are maybe interested in a more sort of out-of-the-box full solution and don't want to do a bunch of custom application development, there are some very mature communities that provide front-end applications and other workflow services around Fedora. The two most popular I've noted here are Hydra and Islandora. I won't be talking about them in this presentation, but do feel free to look them up. There are good presentations online if you want to learn a little bit more about what these applications do. So to begin with, Fedora 4 was conceived a couple of years ago by project stakeholders that were concerned about the Fedora 3 code base. It was kind of stagnating. No one was really working on it anymore. And the software had been around for a number of years and really needed to be refreshed. And so they kind of gathered together and came up with a prospectus that included a number of goals for this new kind of revitalized version of the software. And I've kind of listed them here. I'll cover them briefly, but one is performance, and this is sort of relative to Fedora 3, but having an application that is more performant, more scalable was certainly a major concern. As well, being able to support flexible storage options. In Fedora 3, you were quite limited in terms of how you store things in the repository, and so there's a big desire in Fedora 4 to support many more options for where the data actually lives. Research data management is a major goal, and I can talk a little bit more about that in detail later on, and some of the features that Fedora 4 has that really support the research data use cases. Linked open data support is a major part. It's kind of baked into the core of what Fedora 4 is, and I'll be talking more specifically about that in this presentation. And finally, just having kind of an improved platform for developers. As I mentioned, this is a community source project. Myself as the product manager and Andrew Woods as the technical lead are really the only two employees that are actually paid full-time to work on Fedora. There aren't any developers at DuraSpace that do that, and so we rely on contributions from a worldwide community. And so having a platform that has a code base that is well documented and well tested, and something that developers actually want to work in and has sort of a low barrier to entry for new developers is a really important part of Fedora. I've got this membership slide up here just to kind of indicate that, as I mentioned before, this is really a community project and there's no grant funding for Fedora. So all the funding actually comes from the member institutions that use the software. So DuraSpace is a not-for-profit organization that is member funded, and all of these institutions from all over the world commit funds on an annual basis and direct those funds towards Fedora. And so that gives us the opportunity to pay for 2 full-time employees on the project, host training workshops, do sort of outreach for the software, and any other things that the members see as priorities. And in fact, these member institutions also have opportunities to participate in the governance of the project and kind of dictate the strategies and the direction that we go in. And so you can see here we've actually managed to increase the overall level of funding over the last few years. And the major bump between 2012 and 2013 was the announcement of the Fedora 4 project and the set of goals and opportunities that we saw for this new version of the software. So the community is very much behind this direction that we're going in. And we've managed to raise the funding to a level now where we're kind of approaching more sustainability, which is really the goal here, is to have sustainable year-over-year funding distributed amongst many institutions that use Fedora, so that we don't risk losing too much funding year over year if one or two institutions aren't able to keep up their commitments. So that's sort of the way the project is going in terms of sustainability. But the focus of this presentation, of course, is on kind of an overview of the software itself. And so that kind of tells you a bit about the community. But now I'm going to talk more about the core features and the kind of use cases that Fedora 4 supports. So I'll start here just with a brief architecture diagram. This is pretty simplified, but it does give you a sense of what it looks like under the hood. And you can see here that I actually don't have a lot of custom code. The middle layers there, ModeShape and InfiniSpan specifically, are their own open source projects with their own communities. ModeShape is a repository application, and InfiniSpan provides distributed caching and clustering as well as configurable storage. And so Fedora 4 really is basically this kind of framework of REST APIs is built on top of these applications. So that just kind of gives you a picture of what that architecture sort of looks like. And the reason for that really is kind of moving towards existing standards. We learned a lot in previous versions of Fedora that the community sustained a large maintenance issues. So we're really moving towards adopting existing standards, finding purpose-built applications that we can integrate with. And so being able to kind of have a better way of maintaining the software feature given the sort of distributed open source community that we're working within. So we have fewer customizations to maintain, and we also have opportunities to participate in these related communities. So we can participate in the ModeShape community, we can participate in the InfiniSpan community, and if there are other communities that are working on applications that we want to integrate with Fedora, we can work with them as well. So it gives us lots of opportunities there for interactions. And I mentioned before, one of these standards that we're really pursuing in Fedora 4 is linked data. You may have heard that the W3C relatively recently released a recommendation called the Linked Data Platform, or LDP. And this is this is a full recommendation. That's the highest level that W3C does. So it places this kind of the same level as something like CSS or HTML. It's an established standard now, although it's a new one. And it kind of defines an interaction model for how applications on the web can interoperate with each other using linked data concepts. And so this is really powerful as a way of kind of being more interoperable and adopting a standard for how we use and work with linked data in the context of Fedora. It gives us opportunities to do things like adopt RDF metadata schemas and use RDF properties to represent that metadata on a particular resource in the repository. And really just kind of opens the door for being able to share resources on with other applications, not necessarily Fedora applications, but those that also implement this recommendation. And so the interoperability benefit is really one of the chief benefits here. Is different Fedora implementations that maybe run different front ends or different application workflows can interoperate better, because under the hood, all of the way that they're creating and organizing digital objects is the same. They're using the same kinds of standards for organizing their information. And as well, it allows Fedora to better participate with other applications that maybe don't know anything about Fedora. So as clients for linked data become more popular and other repositories implement linked data specifications, they could interoperate with Fedora using the REST APIs or the messaging service without knowing anything about the underlying technology. And so really the big benefit here, other than interoperability, is also discoverability. You can use Fedora as a server to publish your linked data, and other applications that understand linked data can consume this without knowing anything about Fedora and link back to your assets and make your repository and its contents more discoverable. So as I mentioned, the linked data platform, this is the standard that Fedora is implementing for doing things like creating, reading, updating, and deleting objects. Your basic CRUD functionality, but basically anytime you create or edit something or delete something in Fedora, you're doing that in accordance with this linked data platform recommendation. But Fedora also provides a number of other features that we consider core features, and these are provided via a set of REST APIs. And in each case, we're either already have a standard or we're trying to adopt a standard as a way of doing this. So I'll go through these briefly. Versioning, obviously, is a service that Fedora offers. So if you change or update an object in Fedora, you can create a new version for that. You can also create new versions for the files that are associated with that digital object. So if you had a digital object that represented a journal article, for example, you might have files like a PDF or a thumbnail or other files that are kind of associated with that. And all of those can be versioned, and it's completely optional. So using the REST API, you can create a version whenever you want. Memento is an emerging standard for doing this. We haven't fully adopted it yet, but it looks like it might be a good standard to adopt, and then we wouldn't have custom code for doing versioning. We'd be using an existing standard for how to handle that. Authorization is another core feature, and this is a pluggable one. So there's sort of a framework, and you can plug in different authorization modules depending on how you want to handle security in your repository. So there's a couple of these that exist right now. One is a very simple role-based module. If a user has the correct role that's specified on a particular object, then they can access it. And if they don't have that role, then they can't. So relatively simple. XACML, or Access Control XML, is an external standard that Fedora implemented in version 3 and can also implement in version 4 to give you much more granular access to authorization. And another W3C recommendation that isn't fully a recommendation yet is Web Access Control, which allows you to define authorization using RDF, assertions about authorization using RDF. And so this is something that Fedora could also adopt as a standard. Transactions are another service that the repository provides, and this is very new. These did not exist in Fedora 3. Transactions basically provide a way of bundling up a number of actions into a single event. So you maybe want to create an object and then add some metadata to that object and associate a number of files. And normally you would do these kind of one at a time, and each operation would be written to the disk and take a little bit of time. Using a transaction, you can actually set these up ahead of time and then click a button to commit that transaction all at once. So you get consistency in the sense that everything happens at the same time. You also get a performance increase in that you're writing data to disk fewer times, and so it's faster. Fixity is another service that Fedora provides, and so basically when you ingest a new object into Fedora, you can provide a checksum for that object, or Fedora can calculate one for you. And then at any time, you can use the Fixity API to recalculate that checksum. And that's basically just going to tell you if you had some corruption in a file. If the bits have changed over time, then the checksum will be different, and Fedora can alert you that that file has changed, and you can restore a previous version or take some other action. One way to do that restoration is using the import and export functionality. So rather than backing up and restoring the entire repository, which you can do, you can also export a single object or any number of objects in a serialization format. The standard that we tend to be converging on here is RDF in whatever flavor of RDF you want, RDF XML, JSON LD, or Turtle, or any number of other serialization formats. And then at any time, you can re-import that into the repository for disaster recovery or things like that. So those are just sort of the core features that Fedora provides, but there are also a number of non-core features. So as I mentioned, Fedora is very much about integrating with other applications and services, and you can do that using a framework like this. So this is the same architecture diagram that I showed before, but with the addition on the left of pluggable modules. So Fedora has a very well-defined pattern for plugging in external modules. If you wanted to plug in an OAI PMH module, which does exist, or other modules that are external to Fedora but want to interact with it, you can do that through a well-defined pattern. And on the right-hand side here, you see integrations that are done through the messaging service. So anytime anything changes in the repository, if you create an object, edit it, delete it, whatever, Fedora emits a message. And that message can be consumed by an application, and that application can do things with that message. So what we've been using for this is Apache Camel. So Camel is a well-established project in the Apache Foundation that allows you to basically handle any kind of event-driven workflow. So there's an there's a Camel component for Fedora that you can stand up, and it basically just sits beside your repository and listens for messages. And when it gets a message, it can do pretty much whatever you want with it. So Camel integrates with a whole bunch of other projects in very standardized ways. So you can do things like get a message and index that to an external Solr index, for example. or perhaps you want to index to an external triple store. And I should mention here that Fedora itself doesn't provide searching or Sparkle endpoint or any of that kind of functionality in the repository. Instead, the expectation is that you'll use external applications that are kind of purpose-built to do this much better than we could build into Fedora. And there's just a very well-defined framework for doing that kind of stuff. And right now, that's done through Apache Camel. And so I'll finish off here by talking a little bit about some of the performance and scalability around Fedora, because I think this addresses a lot of the use cases, particularly around research data or very large files or having many files. So there's a lot to kind of say about that in the context of Fedora. This is sort of an architecture diagram to give you a sense of how storage works in Fedora, because as I mentioned, it's much more flexible in Fedora 4. So on the left-hand side, you see this sort of architecture that was very similar to the way it was in Fedora 3. You have a file system that plugs into Fedora, and you ingest directly into the repository and store things on a file system that's attached to Fedora. So that's a very common use case in the way that most people will probably use the application. But you can also project Fedora over an external file system. And this is a really powerful feature. So if you had, for example, a file system that you're managing externally that has very large research data sets, or maybe has uncut master versions of videos that are terabytes in size, for those kind of very large files, you want to move them as little as possible. And so rather than kind of taking all that data and ingesting it into Fedora, which can take a while, you can actually have Fedora sit on top of that file system and project over it so that the data in the file system looks like it's in Fedora, that looks like Fedora objects and can be manipulated, and you can run preservation services and things like that on it. But you don't actually have to go through the difficulty or the sort of time-consuming process of doing the ingest. So this is a really powerful way of supporting large external file systems without actually having to worry about ingest. Future, and this is really within the next 6 to 12 months, we have it on our roadmap to support sort of asynchronous services. So if you wanted to interact with something like Amazon Glacier or a hierarchical storage management system that deals with tape drives, you need a system that can kind of issue a request for something and then wait maybe hours, maybe even days if we're talking about a tape robot, to return the file that we've actually requested. And so that requires an asynchronous API and support for asynchronous storage. And that's something that's the Fedora community has already kind of spec'd this out, and there are people interested in implementing this. So in the near future, this will be another for having external support, and really opens the door for potentially of storage in Fedora if we're talking about all of the stuff that you can get onto tape drives in HSMs. And so we do have some metrics here. We've run some tests in terms of the scalability. And if you go on the Fedora wiki, I have some links at the end here. You can actually view the charts and graphs from these tests if you want to see what the numbers look like. But basically, we've done a number of tests. So we've uploaded very large files, pushed a file about a terabyte in size over the REST API and didn't encounter any problems there. A terabyte's by no means is the limit, but we haven't encountered any bottlenecks doing that kind of operation. We've also, using the projection feature, so hooking Fedora up to an external file system, we've had Fedora manage 16 million objects via projection and didn't see any major bottlenecks or areas of there. And in terms of the sort of standard ingest through the REST API you would normally use Fedora, we've done that with 10 million in a test environment, and again, didn't really see any major degradations in that scenario either. These are certainly not the limits. These aren't the sort of upper end of what you can do with Fedora, but just meant to demonstrate that we have done some performance and scalability testing and really haven't encountered any major problems with that. And then finally, another way that you can sort of support these scale use cases is to use the clustering feature. You can take two or more Fedora instances or nodes, you can cluster these together in kind of a replication scenario. And so the use cases this is meant to support is sort of the high availability use case. And I've actually got a bit of an error on this slide. The third bullet really should be more about the other way you can use this, which is not redundancy, but having sort of better read performance. So high availability is really when you would set up let's say four nodes of Fedora. Each of them looks exactly the same. So you would ingest to one node and it would replicate to the others. And then if one of those nodes in the network goes down, you can have the other ones still be available, so you don't actually lose any uptime on your repository. The other scenario is to get better performance by having something like a load balancer sitting in front of this cluster, so that whenever a user visits your repository, the load balancer will push the traffic to whatever node has the least amount of load on it. And so that can give you better performance for the kind of read scenarios where visitors are visiting your repository. So I'll just finish off here with just mentioning some useful resources if you're interested in kind of learning more about Fedora 4 and to offer. There's documentation that you can check out. All of these links are embedded in the slideshow, so I'm sure we can provide that afterwards. But the Fedora 4 wiki has really extensive documentation for users, as well as administrators and developers. And I've kind of split them off here. The documentation deals with the current version, and then the wiki space has a lot more stuff in there, things like meeting minutes and notes, and sort of some information on current development projects and the roadmap and things that are not sort of built in yet, but kind of upcoming. But one of the best ways to interact with the project is through the community. So there are a number of mailing lists that are very active. The Fedora community mailing list has almost 1,000 members and thousands of topics on it and lots of traffic. So it's a good way to get updates, but also to ask questions. So I'll leave off there. I've got some contact information here. Feel free to get in touch with me directly if you do have some questions, or I believe if anyone does have questions about anything they'd like me to